Okay, we're back here for another episode of troubleshooting the errors. We're looking at the eplusout.err file, and the next warning that we get is calculate zone volume. The zone, thermal zone 1, is not fully enclosed. To be fully enclosed, each edge of a surface must also be an edge on one other surface. And then it says the zone volume was calculated using the opposite wall area times the distance between them method. So that's the first error, and then we're going to look at this next one in a minute because these are two related. But let's talk about this calculate zone volume error first. We'll go take a look at the model. And one of the things that we need to note is that this model has a single thermal zone. So even though you have all of these different spaces, when this thing gets passed to EnergyPlus, it becomes one big blob, and it's a combination of all of the spaces. You know, it's an average of all of these different spaces. And if we take a look at this rendered by thermal zone, you can see it's just one thermal zone. There's no other colors. So this whole thing gets passed to EnergyPlus as a single piece of geometry, a single zone that's would be controlled by basically a single thermostat. But it's complicated because there's complicated geometry, and what EnergyPlus is saying is, with this error, calculate zone volume, it's not fully enclosed. What EnergyPlus is saying is, well, there's a piece missing somewhere. Say there's like a hole or something in your geometry, and EnergyPlus is saying, well, this is not fully enclosed. There's a hole somewhere, so I can't calculate the volume based on the surfaces. So what EnergyPlus does instead is it calculates the distance between, say, this wall here and this wall here, and it multiplies it by the area of this wall. And it's EnergyPlus is assuming that this is basically just a rectangular thermal zone. But it's not. And so EnergyPlus tends to make very big mistakes on this. So there's two ways you can do that. You can solve the problem, like you can figure out where the hole is and try to patch it up. But sometimes that's not successful because the holes can be very small, or there could just be some mismatch in your lines that are connecting the spaces. So the other way to fix that is to hard size the volume and the floor area. So basically you would manually calculate what the floor area is, and then you would enter it in here in the thermal zone in the OpenStudio inspector, and then you would calculate the volume and then hard size that right here. So how would you do that? What you can do is have SketchUp do it for you, and we'll just open up another instance of SketchUp. And what we're going to do is just copy all of this. So we're going to do a Control A, Control C, and copy this. And then what we're going to do is we'll just do a Control V, and we'll just paste it in here. So we've got our model pasted into another instance of SketchUp, and now we're going to do a Control A to select everything, and then right click and explode the whole thing. So that destroys all of our spaces that we created. It just makes the model dumb. All of these surfaces are at the very top level, and it's all one big mixture of surfaces. And then what you can do is we'll just do a side view and change the perspective. And then what you can do is you can go through here and just delete. We'll just delete all of the walls, or we'll try to delete all of the walls. This gets kind of tricky, especially if you have windows. So I've got most of it deleted, but and then what you can do is you can open up the default tray entity info. Entity info, and if you click on any one of these surfaces, SketchUp will show you what the area is. So you could go through and add all of these up. Alternatively, you could have SketchUp calculate that for you. So we'll just hide this for now. Click hide, and then we'll do a top-down view of this. And what we can do is we can just delete all of these floors so that it's just one big floor. And so we've got one big floor, and then if you just add one line here, it should connect everything up into a surface. And then if you click on that surface, that'll give you the total floor area right here, 12,435. And then you can go into your model and hard size the floor area. You click hard size and then put in 12,435. And then the same thing you can do for if we do unhide all. Unhide all. If you unhide everything, what you can do is you would still need to go through and probably delete these windows and stuff. But what you can do is delete all that windows, and then you start connecting this together into one piece of geometry. You might actually even have to delete all of these ceilings too, but once you have the whole thing patched up into one big piece of geometry, you should be able to click on it, and SketchUp will tell you what that volume is. And I'll just do a sample here. We'll just delete most of this here, and we'll just focus on this here. So if we well, this is kind of an odd shape. Well, I'll just show you something real quick. We'll just draw a rectangle and then push-pull it. So, if you click on the surface, like I said, SketchUp will tell you the area. But if you select the whole thing and do a make group, then SketchUp will tell you what the volume is right here. And that's basically what I did with this. Is I blew away all the walls, the floors, and the ceilings, and I reconnected everything up, and so it was one continuous piece of geometry. And then I had SketchUp calculate the volume. So that's one way around. One way for solving this calculate zone volume error. And that's basically the way you solve it if you have complex geometry. But we're going to go into this a little bit farther because this error is actually connected with this other area. With this other error. So the next error says the surface 10, has an edge that is either not an edge on another surface or is an edge on 3 or more surfaces. And then it tells you what the vertex start and end point is for that edge. So if we go back to our model, and we can go to the inspector tool and we can look at surfaces, and in this instance we are looking at surface 10 has the error on it. So if we look at surface 10, sometimes it's difficult to find these, so we can put it in X-ray mode, and if you still don't see it, you can go to edit, face, select all connected, and then it's a lot more apparent where that surface is. So it's going to be on this volume here. So surface 10, and surface 10 is actually this surface right here, and you can click on it. So that's surface 10. And I would suspect that because this is saying that it has an edge on another surface or is an edge on 3 or more surfaces, I would suspect it's probably talking about this edge right here. It's this edge right here, because it's connected to this space, it's connected to this space, it's connected to this space, and it's connected to this space. So it's sharing an edge on 3 or more surfaces. And the reason OpenStudio is giving you that error is because OpenStudio doesn't recognize this wall as an interior wall. It got imported to OpenStudio as an exterior wall, and it got exported to EnergyPlus as an exterior wall. So EnergyPlus is saying, hey, why is this edge surrounded by other surfaces? It should be on the outside, like this edge. So, with that said, how do you solve that, and why are we having that problem? Well, it's because, like I said, this whole thing is considered a single thermal zone, and it's getting imported to EnergyPlus as a single thermal zone. What we could do is separate these out into their own individual thermal zones, and you can do that by changing the attributes on these spaces. So you could go to the set attributes and create a new thermal zone. Or what you can do is what's called surface matching, and that tells OpenStudio EnergyPlus which surfaces are going to be exterior surfaces and which surfaces are going to be interior surfaces. So to do that, we would go to the surface matching tool, and what you want to do is intersect an entire model first, just to catch any missing surfaces that are not matched. So when you do surface matching, you want to make sure that this surface here is the same geometry and area as the opposing surface, which would be on this side here. And what it's going to do is it's going to match those surfaces together, and it's going to say, hey, this surface here is going to be sharing heat transfer with this surface here. And that way we know that it's an interior wall. So if we do intersect an entire model, and it says that it's irreversible, so you want to make sure that you're okay with that, or if you've saved the model beforehand. We'll click OK. So it's matched all the surfaces, and then you can click Match in Entire Model. Again, you want to save it to have a backup just in case something goes wrong. And click OK. And then it's done. And how do we know that it matched? Well, you can go to Render by Boundary Condition. We'll go back to X-ray mode. And you can see that all of these interior walls are green now. They used to be blue, and that's saying that, hey, this wall right here, this surface, has been matched to the other surface on the other side. And so now EnergyPlus knows that heat transfer is occurring between those two surfaces, that those surfaces are interior, and so you will no longer have that edge error here saying that the edge is either not an edge on another surface or it's sharing an edge on 3 or more surfaces. So with that said, let's go ahead and save our model, and we'll just go save it as a 4. And we can open up our model. Let's see here. And we will now run the simulation and see if we get that error. Alright, the model has run successfully. Let's go ahead and open up that error file. We're going to have to open up the newer version of it that we saved. Go to the Run folder, eplusout.err. And then it's still telling us that there is this thermal zone 1 is not fully enclosed. So there may still be some geometry errors in this. So that's a good thing that we hard sized that volume. And then it also says surface 2 has an edge that was used 6 times. So apparently some of these interior zones are causing errors. But what we really should do, like I had mentioned before, is separate all of these spaces into their own thermal zone. So how would you do that? There's a real simple user script in SketchUp that you can use, but first we will go to the Thermal Zones tab in OpenStudio, and we'll delete this thermal zone. Save it, and then we will reload it in SketchUp. And if we go to render by thermal zone, you can see that there are no thermal zones assigned. So what we can do is, now we don't have any of these spaces assigned to a thermal zone. We can go to the Extensions, OpenStudio User Scripts, Alter or Add Model Elements, and add new thermal zone for spaces with no thermal zone. And I cover this in one of my other videos. Now that we're rendered by thermal zone, you can see that each one of these spaces now has its own thermal zone. And we'll go ahead and save the model. And we'll go ahead and revert to the saved in OpenStudio. And we will go ahead and you can see that all of these thermal zones were created. And we'll go ahead and now we'll run the model. and the model was run successfully. And if we go back to our error file, we'll reload it, and you can see that a lot of those errors have been resolved. It's still calculating a zone volume for thermal zone 6. It's saying thermal zone 6 is not fully enclosed. So again, we would have to go to, we would have to find that thermal zone 6, and we'll browse for it in the inspector tool, and here we go. This was thermal zone 6. So thermal zone 6 is obviously having some issues. It could be a very small gap in the wall, or really anything. But like I said, you can hard size these. You can say that the floor, you can calculate the floor area, and you can calculate the floor area, so 1682 square feet. And if we render by thermal zone, we can say that the floor area is 1682 square feet. And again, you can calculate the volume, like I said before, using SketchUp. And you can hard size the volume in there. So that's how you solve the calculate volume error. And then the next error, surface 25 has an edge that was used only once. It is not an edge on another surface. So let's take a look at surface 25. We can click surfaces, scroll down to 25, and find out where that is. We will select all connected, and it looks like, yeah, surface 25 is actually associated with this thermal zone we were having issues with. So surface 25. So here we go. It's this surface here. And what is it saying? It's saying that it's not an edge on another surface. If we go back to 25, you can see that this surface 25 is an exterior surface. So that's true. It's not an edge on another surface. And in fact, it looks like we found our gap in this volume. So if we fix this hole, that may correct the zone volume for that space. And it may fix those errors. Again, likewise, thermal zone 7, it's not possible to calculate volume, and again, we might have one of those holes in our spaces. So we'll go ahead and try to resolve those errors. But anyway, that's enough for today, and that is how you solve those two errors. Thank you. Please like and subscribe.